Hello there. Today's lesson is 4.1 Angles and Radian Measure. This lesson packs a lot of information, but I talked to the Algebra 2 teacher before I did this, and everything you have done on here except for the last one. So this should be a review, and we should be able to go through it very quickly. So first off, we're going to review the vocabulary of angles. We're going to talk about degree measure, radian measure, converting back and forth between degrees and radians, angles in standard position, finding coterminal angles, the length of circular arcs, and the new thing will be linear and angular speed to describe motion on a circular path. So to start off with and refresh you on what an angle is. An angle is two rays that have a common endpoint. That endpoint is called the vertex. One ray is called the initial side and the other is called the terminal side. Okay, you had that in geometry and talked about it again in Algebra 2. So we talk about an angle being in standard position if the vertex is at the origin and it has an initial side on the positive x-axis. So both of these, the blue one, the initial side's on the positive x-axis. It does not matter where the terminal side is. So standard position, vertex at the origin, initial side on the positive x-axis. Okay? Now, the other thing you need to remember is angles are positive if they rotate in a counterclockwise motion, and they are negative if they rotate in a clockwise rotation. So this angle here is positive and this angle here is negative. So really what's important and what you need to remember about this is that this arrow is very important because it's telling you the direction of the angle and whether the angle is positive or negative. So another type of angle that we have is one called a quadrantal angle, and that is an angle whose terminal side, terminal side is on an axis. So this is the terminal side of the angle, and it's on any axis. Initial side still in standard position because the initial side is the positive x-axis. Okay. Again, to refresh your memory, we know that a complete rotation of a circle is 360 degrees, but we have an angle that is an acute angle that measures less than 90. A right angle measures 90. An obtuse angle measures more than 90 but less than 180. And a straight angle measures 180 degrees. Okay? Now, I know that you've talked about radian measures. You talked about it in geometry and again last year. But the radian measure of an angle is just the arc divided by its radius. Okay, so if you want to look at it in a formula set, what you need to think of with radians, 360 degrees is all the way around the circles, what we just talked about here. Okay, radians allow us to keep our units smaller because the definition of a radian is when the length of the arc is the same as the radius of the circle, then we say that the measure of that central angle is 1 radian. So this particular angle here has a measure of 1 radian because the arc that it intercepts right here is the same length as the radius of the circle. So really ought to stop and think, how many radians does it take to go all the way around the circle? Well, you're going to see it come up, but before we go there, we're going to talk about some other things first. A radian measure, and we have to talk about what is called the arc length. Okay, it is denoted by the letter S. Okay, you have your radius and you have your angle. Okay, theta is defined, as I just said, is defined as the arc length divided by the radius. That was the when I just told you that what 1 radian is. So you need to remember that theta is S over R, and we'll have a variation of that later. But a central angle theta, this is example 1, a central angle theta in circle of radius 12 feet intercepts an arc of length 42 feet. What is the radian measure of theta? Well, I'm looking for the radian measure. The radian measure is theta equals S over R. So in this particular case, theta S in my problem is 42 and R is 12. So the radian measure of this angle is 3.5 radians. Now, how do we convert between degrees and radians? You're going to remember the basic relationship that pi radians is equal to 180 degrees. And one of the ways that I remember this is whatever you need to go to. So to convert degrees to radians, then I'm going to put radians on the top. If I'm going 2 degrees, then I'm going to put degrees on top. If you think about, y'all, 12 inches is equal to 1 foot. If I'm converting 2 inches, then I want 12 inches on top and 1 foot on the bottom. If I'm going to feet, then I'm going to multiply by 1 foot over 12 inches. So it's a similar thing. Here are several examples. 2, converting from degrees to radians. So when I want to, oops, I didn't want to do that. When I go 2 radians, then I'm going to take my 60 degrees. I'm going to put it over 1 because I'm multiplying by a fraction. And then I'm going to go 2 radians, so I want pi on the top and 180 on the bottom. And that is equal to pi over 3. If you have any trouble here, y'all, okay, I can talk to you about the fact that the zeros on the top cancel, but most of y'all want to put that in your calculator. Just use the fraction button. Put 60, fraction bar 180. It will tell you 1/3, and then you put the pi back in the top. That's how you use your calculator to do it. Okay, the next 270. I need to go 2 radians, so radians is going to go on top. Pi is going to go on top. And again, put 270 fraction bar 180 in your calculator. It will tell you 3 over 2, but you got to put the pi back in, so it's 3 pi over 2. Now look at this one. Again, negative 300 over 1, again, times pi over 180. But the most important thing is a lot of people are going to forget that this negative carries all the way through the problem. So the answer is negative 5 pi over 3. If you do not know how to use the fraction button on your calculator, you need to come see me. I can help you do that. All right, example 3, we're going to go the other way. And instead of going 2 radians, this time we're going 2 degrees. So I have pi over 4. I'm going 2 degrees, so 180 is on top and pi is on the bottom. And I hope y'all can see there that my pi's are going to cancel out. So again, 180 divided by 4 is equal to 45 degrees. I will say that radians, the last examples that we did, radians are the one unit label that you don't have to put. But if you don't put a degree symbol, then it's assumed to be radians. So you got to put the degree symbol when you're going 2 degrees. All right, negative 4 pi over 3. Again, I'm going 2 degrees, so 180 goes on top, pi goes on bottom. And again, in your calculator, do 4. You got 2 ways of doing this, y'all. You can do 4 times 180 divided by 3, or you can use the fraction bar, but you do have to give an exact answer. And in this case, it would be 240 degrees. Now, were y'all paying attention? That negative sign got left off of there, okay? So remember, as I just said earlier, if it starts off negative, your answer is going to be negative. So you can't forget that. All right, look at this one, 6 radians. Again, 6 over 1 times 180 over pi. So when you do this one, this would be one that you're going to round to whatever MyLab Math tells you to round to. So 6 times 180 divided by pi, I took it out one place, that's 343.8 degrees. Okay, let's talk about drawing angles in standard position. Okay, when you do that, okay, all the way around is 1 full revolution, and that is 2 pi. Okay, if you notice when we were talking about our going back and forth, our conversion factor, okay, we knew that pi was going to be the same thing as 180 degrees, and 180 degrees is halfway around our circle. So half of a revolution is pi radians. A full revolution is 2 pi radians. 3/4 of a revolution is 3 pi over 2. And then 1/4 of a revolution is pi over 2. So those numbers are going to be really important. If you don't know them already, I'm going to talk about them in the next lesson with our unit circle. The other thing that you're going to be asked when you do these problems is you got to remember your quadrants. So remember, positive is quadrant 1, and then we go in a counterclockwise direction. So this is 2, quadrant 3, and quadrant 4. Okay, so the next examples are for angles in standard position. And the directions say draw, but I changed it the last minute because I wanted it to be like what you do in your homework. And in your homework, you're going to have multiple choice. So what you have to remember and understand is where pi over 4 is. And in this particular example, I'm using the first one here because it's easiest to read. Okay, but you're going to see these 3 tick marks. And the one in the middle is halfway. So this was pi over 2, which means the one in the middle here is going to be pi over 4. And one of the ways of thinking about that, y'all, is if halfway around is pi, then that's 1/4. Okay? And this one down here is going to be pi over 6. And this one up here is pi over 3. So this is dividing it. I didn't do that very well. Dividing it into thirds, dividing it. And when I say thirds, I'm talking about half of the circle. If you divide it into thirds, you would have one piece here and one piece there. If you divide it into fourths, this is 1/4, 2/4, 3/4, and 4/4. But we're going to talk about that a lot tomorrow. So what you want to remember is 4 is in the middle, 3 is closer to the top, 6 is closer to the bottom because that's a small piece, and it always starts from the x-axis. So if I need negative pi over 4, negative is a clockwise direction. So if I need a clockwise direction, then this is counterclockwise. This is counterclockwise. That's D is clockwise and A is clockwise. So which one is negative pi over 4? Well, as we just said, pi over 4 is the one in the middle, and this is going to be that angle right here. So the answer is A. All right, look at 3 pi over 4. So the pi over 4s are in the middle. All right, it is a positive 3 pi over 4. Okay, well, we just talked about this one being 3 pi over 2. Positive, that's a negative angle. That's a negative angle, so that wasn't very hard, hopefully. So one of the ways when you're doing it, pay attention to whether it's positive or negative, and your choices are limited, makes it easier to get the right answer. All right, negative 7 pi over 4. I'm going negative. That means I'm going clockwise. So A is not negative. That's a positive angle because it's going counterclockwise. B is a negative angle. C is not a negative angle. And D is a negative angle. So I have to look and see which one is 7 pi over 4 between these two. 7 pi over 4, y'all. You think about the one in the middle and you count. So if I start, this was pi over 4 up here. This one right here. So, and up here is 2 pi over 4, and 3 pi over 4, and 4 pi over 4, and 5 pi over 4, and 6 pi over 4, and 7 pi over 4. So 7 pi over 4 is going to be almost all the way around the circle. And so the answer is going to be B. This one is actually negative 3 pi over 4. All right, last one of drawing an angle in standard position. This one is 13 pi over 4. So notice these dots because this one goes around the circle more than once. And I think the easiest way to do these problems is to divide 4 into 13, which your calculator will do for you. But it goes 3 times with 1 left over, which is like 3 1/4 pi, or 3 plus, actually, let me just do it like that. So 3 1/4 pi is like 3 pi plus pi over 4. Okay, so when you're doing it, remember 0, I'm going to start over here. 0 is here. Okay, pi is here. And 2 pi is here. which means 3 pi is over here. Because I'm going 0, pi, 2 pi, 3 pi. And then I have another fourth to go. So it really should end up here. And you know what? I just realized we didn't talk about what quadrant each of those is in. So the one that's got to be the answer is this guy here, because this goes all the way around. That's 2 pi, 3 pi, and then to here. So my answer is D. This is in quadrant 3. Like I said, I just realized they're going to ask you what quadrant this is in. This is in quadrant 1. This one is in quadrant 2. That's where it ends. And this one is in quadrant 4. So you have to answer both of those questions when you're doing these problems in your homework. All right, coterminal angles. Coterminal angles are two angles that share a terminal. They have the same initial and the same terminal sides. Okay? That's what coterminal angles are. They always differ by 360 degrees or 2 pi radians. So if you need to find coterminal angles, you're just going to add or subtract 360 or add or subtract 2 pi, depending on what the problem is. So in this particular case, this example, find a positive angle. That's not what I wanted. Positive angle less than 360. So I've got to get 400 that's coterminal. Sorry. So I've got to get 400 to a number between 0 and 360. So I'm going to subtract 360 from it, and my answer is going to be 40 degrees. Okay, look at negative 135. This one I'm not going to subtract, because if I subtract 360, I'm not going to be positive. So I'm going to add 360 to this one, and when you add 360 to that, you get 225 degrees. All right, in a similar fashion, example 8 was degrees. Example 9, we're doing the same thing, but this time we're going to be using radians. Okay, so I have 13 pi over 5. And y'all, when you're dealing with this, again, you can use your calculator to do it, but you just, actually some of them, the black one will allow you to keep your pi in there. So you need to try this with your calculator or try it by hand. And if you have any difficulty with it, please put a star by it and ask me about it in class. Okay, 13 pi over 5, and I'm going to subtract 2 pi. Well, 2 pi is the same thing as 10 pi over 5, because 5 goes into 10 2 times, or 5 times 2 is 10. So that gives us an answer of 3 pi over 5. If I have negative pi over 15, okay, I need it positive, so this time I'm going to add 2 pi in terms of 15, so that's 2 times 15, or 30 pi over 15, which is 29 pi over 15. Again, let me know if you need help with your calculator. All right, the length of a circular arc. So we already talked about, y'all, we talked about earlier that theta was equal to S over R. Well, if I need to solve that for S, I'm going to multiply both sides by R. So that's our next formula. The arc length is S equals R theta. So straight up, a circle has a radius of 6 inches. Find the length of the arc intercepted by a central angle of 45 degrees. Express the arc in length in terms of pi. LOL. And then round your answer to, then round your answer to 2 decimal places. Okay, so our formula is S equals R theta. And so what is R? R is 6 in this case. That's the radius. Now, whenever you use that formula, I don't think I emphasized this, but whenever you use this formula, you always have to make sure your angle is in radian measure. So in this particular one, central angle of 45 degrees, yeah, I can start with 45 degrees here, but I have to change it to radians. So if I have to go to radians, then I'm going to multiply it by pi over 180. And I did not simplify that in terms of pi, which is what they told us to do. So that would be 3 pi over 2. That would be 3 pi over 2 inches. That's another thing about arc length, y'all. They do always want a label with it. Okay? And then when you convert that to a decimal, that's what you get. All right. Okay, we're on the home stretch. Definitions of linear and angular speed. Okay, so the linear speed is defined as S over T. S is our arc length, remember? R theta. Okay, that is the linear speed. And then we have something called angular speed. And angular speed is defined as theta over T. So lest you get confused by that, okay, remember S equals R theta. So another way of thinking about it is that the linear speed is the angular speed times the radius, which is what that just says right there. The radius times the angular speed. Okay, so if you have any difficulty with this, y'all, the best and easiest way to do it is to keep track of the labels. And I've told you that in a lot of the word problems and applications. Keep track of the labels when you're doing this. It will simplify things. So long before iPods that hold thousands of songs and play them with superb audio quality, individual songs were delivered on 75 RPMs and 45 RPM circular records. A 45 RPM record has an angular speed of 45 revolutions per minute. Find the linear speed in inches per minute at the point where the needle is 1.5 inches from the record's center. So they've asked me for the linear speed, and they gave me the angular speed. So I'm going to use my formula of linear equals the angular times the radius. And I'm going to go and watch. This is one where I'm going to keep my labels in the whole time. So first off, my angular speed is 45 revolutions per minute. So I'm going to keep it in a vertical fashion. It makes it much easier to see what labels cancel. You cannot leave revolutions. You can never leave revolutions in your answer. So if you remember earlier, 1 revolution is the same thing as 2 pi radians. So that is my conversion factor that is going to allow me to get rid of the revolutions in that problem. So I'm trying to go from revolutions per minute to inches per minute. All right, so I got rid of my revolutions. I have minutes on the bottom. I need inches on top, which that's my radius. And my radius is right here, 1.5 inches from the record center. So that's where I'm going to get my inches. And so when you multiply that out, you get 424.12 inches per minute. Notice we did our conversions until I had inches on top and minutes on the bottom. And that is all. Quick review. Thank you so much for watching. If you have any questions, please don't hesitate to ask me. Thank you so much for watching, and y'all have a great day.